topic of today's video is going to be gases and an introduction to pressure. Alright, so let's start out by introducing the concept of a gas. For us in chemistry, a gas is nothing more than a phase of matter, like a liquid or a solid. Now, gas as a phase of matter is going to be defined by its shape and its volume. Specifically, there is no definite shape to a gas. In other words, if we put a gas into a container, it's going to take the shape of its container. And also, gas has no defined volume. So again, what that means is that a gas will expand to fill its container. All right? Now, that's because when we think about a gas, what we really are thinking about is particles of matter that are far apart and moving. So the assumption here is that the particles are far apart enough that they rarely interact with each other when they actually collide, which is actually quite infrequent. As a matter of fact, one of the assumptions we're going to make about an ideal gas later is that the particles never interact with each other. Alright, so keep in mind with a gas, the particles, unlike in a liquid or a solid, are very far apart and they almost never feel each other. Now, when we want to talk about gases, we can use a number of variables. But one of the primary variables that we talk about when we deal with a gas is the variable of pressure. Alright, so in many cases when we want to evaluate a gas, we're going to talk about, for example, the pressure exerted by that gas. So that means we have to come back and think about what pressure actually means. Now, if we go back to our very simple physics definitions, what we will recognize is that pressure is a force exerted over a given area. Okay? Force is given in units of newtons. And we're going to break this down in just a moment. Now, that force in newtons will be exerted over a given area. So if we're sticking with our standard SI units, we'll consider an area to be a square meter. But just to think about this, if you want to just visualize what a pressure would be, if I were to put my hand down on the table here and press down, I'm exerting a force over an area defined by the area of my hand. So that's pressure. It's a force exerted over a given area. All right? So let's break this thing down into its simple SI units here. So again, going back to our simple physics, we might remember that force is going to be the product of mass and acceleration. So going back to our simple SI units here, mass can be given in kilograms. Acceleration is the time rate of change of velocity. So it would be in terms of meters per second per second. So we can write that as meters per second squared. Now, putting those units together, that's what we call a newton. A newton is a unit of force, where force broken down is kilograms times meters, all divided by square seconds. All right? So now we can all put this back together into our pressure definition here, where pressure is force divided by area. So here's a newton right here divided by a square meter. All right? So if I take a look at this, and I want to simplify it a little bit, I can treat it like a complex fraction here. So if I have a complex fraction and I want to simplify it, what I do is I take the denominator, I invert it, and multiply it by the numerator. And that's precisely what I'm doing here, invert and multiply. And when we do this, what we see here is that the meters are going to cancel here. The meter squared goes away and just becomes a meter. So what I'm going to end up with here is a kilogram per meter times second squared in the bottom. Okay? So altogether, the kilogram per meter second squared is what we call a Pascal, which is our SI unit of pressure. Okay? Another way of thinking of a Pascal is it's 1 Newton exerted over a force of 1 square meter. All right? So that's the meaning of the Pascal. That's our simplest SI unit of pressure. Now, just to put this in terms of something we're used to thinking about, we can talk about barometric pressure. Okay? So when you turn on the weather at night and they talk about the barometric pressure, you know that, for example, a high pressure system means that we have good weather. A low pressure system means that bad weather is coming. Okay, so what we're talking about here is the measurement of the barometric pressure. Now, what is barometric pressure then? Well, it's the pressure exerted by the air in the atmosphere upon us here on the surface of the Earth. Now, when we want to measure the barometric pressure, we measure it using a tool called a barometer, which you guys have probably heard of. Now, the simplest way to construct a barometer is to actually take a closed-end tube like this, invert it, and place it into bottom open end down into a pool of a liquid. And the liquid could be something like water, or it could be mercury, or anything else that we want to use. All right, so what ends up happening here is when the pressure bears down on the liquid in the container or the reservoir here, that's going to force the liquid up the tube. All right, so if I have a high barometric pressure, what's going to happen is I'm going to bear down harder here on the surface of the liquid, and that's going to force more liquid up the tube. So what I do is I actually measure the height of the liquid column from the surface of the liquid. And then what I ought to be able to do is relate that back to a pressure. So I have an equation to do that. So if I'm working with a barometer, the pressure is actually equal to the height of the liquid column, which we can measure here, times the density of the liquid itself, times the acceleration due to gravity, which is a constant. That's 9.8 meters per second squared. All right? So let's just verify that we get pressure units back out of this. It's always a good thing to do when we have an equation, put our basic units back in and make sure we get the units out that we should get. So height will be in terms of meters. The density, if we go back to our SI units, basic SI units, should be a mass over a volume, so we could represent that as kilograms as our mass over a volume in meters cubed, right? A length unit cubed is a volume unit, times the acceleration due to gravity, that's in terms of meters per second squared. There's our meters per second squared. So again, what we can do is cancel things out. So I have a meter canceling with this, making it a meter squared. This meter will cancel with the meter squared, leaving me with meters. So ultimately what I'm going to get is a kilogram, let's see, how did that go? That meter should be in the bottom, sorry about that. Kilograms per second squared times meters. So that last meter should be in the bottom because it cancels in the top. So I think that's correct. And that should take us back to where we were in terms of the Pascal. And that's what we got here. A kilogram in the top, a meter in the bottom, second squared in the bottom, and that matches up. So we end up getting pressure units out of this. Now, the interesting thing about this is normally when we talk about pressure, we don't normally use the Pascal. We're going to have some other more convenient units of pressure that we can use, so we're going to introduce those in class. For example, we often think about pressure in terms of inches of mercury or millimeters of mercury. So that's a unit that we can talk about and see where it comes from. So that's what we're going to do next time in class. We're going to introduce that and then look at some pressure relationships with regard to gases. All right, so we'll see you next time in class.